G'day, my name's Steve and this is Reevesy Workshops. Today I'm going to fix a blown fusible plug. So let's get into it. So you may be wanting to ask the question, what's a fusible plug, Steve? Well, that's a good question. It's a device that's used to protect a boiler against low water level. What I have here is a diagram of a boiler that I made recently, and this is what it looks like from the inside. So over here we have the firebox section, so you'll see the box here. The fire, it burns in this area here. There's all water surrounding it. There's all water in here. These are the boiler tubes where the exhaust gases go out and off into the smoke box and the chimney. Now if the water level was to drop below this plate here, it could damage this plate and possibly other things too. So what you do is you fit a fusible plug here where this threaded section is, and the idea is if the water level drops, it will melt tin in the plug, blowing steam into the firebox area, putting the fire out and reducing the steam pressure in the boiler itself, and that way protecting the boiler. Before I go about repairing the plug, however, I've gone to our boiler book, the AMBSC boiler book, and just checked to see if there's been any changes or updates to the way that fusible plugs are to be made and set up. And I'll zoom in a little bit here. You can see the diagram of the fusible plug there. That's sitting in the crown plate of the boiler, and that's that top plate that I showed you earlier. There's a little bit of wording here telling you about how to set them up and when appropriate to set it up and whatnot. So I'll now go and have a look at the plug and see if it complies with what's required, and if not, we'll modify it to do so. I have the body of the a fusible plug in the lathe now. So what I'm going to do is I'm going to lightly skim the front of it. Its pinky colour is because I've had it in the pickle for several hours to clean it all up, and you can see it's had a bit of a hard life. But anyway, we'll clean it up. After facing it off, I'm going to enlarge the holes in the middle, as I'm going to put a copper plug in it. You see it here. I'm not going to use any lubricant on this, which you would normally do, because I don't want to contaminate it. So just a very light cut. Looks like I need another one. First of all, I'm going to put a 5/16 hole in. It's actually already got a hole in it, but I'm just going to enlarge it. So we've got a bit of material space between the rivet and the hole for the tin to go into. You can see the drill wobbling a little bit here. The plug's not sitting perfectly square in the lathe and in the chuck, and that's because of the damage to the flats. So we'll just make do with what we've got. So now I'm going to open up the larger hole just a little bit more, and I'm going to go in a depth of about 10 mil. Once again, you can see that drill wobbling a bit because the hole isn't perfectly concentric. I'm just taking nice easy cuts so I don't damage anything. Just deburr it, take away the sharp edges. So you can see I've got a nice recessed hole in there now, looking very much like the drawing shown in the boiler book. Turn it round in the chuck now and I see it's sitting much nicer in the chuck, which is good. So I'm just going to take the bits of rubbish that are on the top off. Take another 10 foul cut. Just deburr it. You can see a little bit of the tin left on the surface there, so I'm going to leave it on there because that'll help with the new tin that I melt onto there, help it to grip. So looks ugly, but in fact it'll do the job nicely. So I've just cleaned the edges up to get on the flats, just to get rid of the sharp edges. I mean, it's been a bit mangled. I really should throw it away and start again, but I haven't got time to go down to the supplier to get a new plug, and the owner wants it back pretty urgently so he can run his loco on the weekend. So we'll recycle what we've got and we'll carry on. The rivet's a little bit too long, so I'll just cut it down to size very carefully with my junior hacksaw. Nice and slow at the end so you don't drop it on the floor. See, I can just take it off and don't lose it. It's a bit too short to hold properly. I could file the end or even machine it, but it's a lot quicker to use the linisher. Well, that's looking pretty good now. I've got a bit of a gap there for the tin to flow into. We've got our nice recess as well. So we'll do a bit of smelting. I've got a small piece of tin in the vise here, so I'm just going to very carefully hacksaw some small pieces off. It's a very soft material, so just have to be careful at the end here. You can see it's very soft and breaks easy. There we go. I need to melt the tin and pour it into the fusible bush plug, I should say, and to do that I need a ladle. I made this up many years ago and you can see it's badly rusted. I'm not going to work with dirty equipment, so I'm going to clean it all up. What I have here is my corded electric drill, which I've set up with a wire brush and sitting on a drill stand so I can work outside and de-rust things. Very handy gadget. And there's the sort of result you can get off it. As you can see, you need to be very careful with how you handle your equipment while you're doing it, and make sure your fingers don't get in the way. You can get different types of wire brushes. You can see one here, for instance, for doing flat plate or sheet. This one here, a bit dirty, smaller diameter, but it's actually a brass bristle one rather than mild steel. And I'll just give you another look at the ladle. You can see how well it started to clean up. Ignore my welds. This was one of my practice jobs when I was learning how to electric arc weld. Small wheel gets inside here very nicely. You can just see it's all not polished, but certainly you've got rid of the rusts. Just a bit more cleaning up with a bit of fluid cleaner and we should be right to do some smelting. With the ladle nice and clean, we'll melt this tin. So I've got a nice block of tin here, probably more than what's needed, but that'll do. This is going to be a bit of a long process, so I'm going to do it off camera. Hopefully come back on camera again when we're ready to pour. When it came time to melt the tin into the fusible plug, I had a lot of difficulty because there's a fine line in temperature between melting from a solid into a liquid and then into a gas, and it's very easy to heat the tin too much and vaporize it. I had several goes in my home workshop and I just wasn't quite getting it. So once a week we have an open day with one of our members at his workshop. So I decided to go and see the Brains Trust and see if they can help me out. And these two photos show you what we did. So in the first one here, you can see that we had a professional ladle, so we're able to melt the tin in the ladle. You can also see that there is a bigger burner here. So this is putting out a bigger flame and heating this in a more controlled manner. This photo is showing you that we've got the tin almost at the melting stage, and here's the fusible plug ready to have the tin poured into it. And the process was to have one operator carefully heating the tin, then the second operator would grab the crucible, pour the tin into the bush. That would immediately solidify. He then got his oxy torch, heated the bush and melted the tin inside. Meanwhile, the first operator was reheating the tin again, getting it to lead. Then a second pour was done to fill the gap. Heat up again by the second operator and melt it. And the process was repeated about 3 or 4 times. And finally, we got the tin to melt and to flow into the fusible plug without vaporizing it. And here's the finished result, all completed and all ready to go. So if you want to have a go at doing this yourself, that's the method I recommend you take. Anyway, we got there in the end, despite the challenges. Very pleased. Now the owner of the fusible plug will be able to give his engine a run. And that concludes the tutorial on machining a fusible plug and tinning it. Just goes to show that sometimes we face a few challenges in the hobby, and this certainly was one. But with the help of a few friends, we're able to overcome it all and produce a good result. See you next time.